Dear student, welcome to you the new topic in the boiler or the continuation of the boiler. In previous tutorial we have discussed the low pressure boiler. Now this time there is a high pressure boiler. In high pressure boiler there is two classification is to be given. One is called the subcritical boiler, another is called the supercritical boiler. Subcritical boiler are those boiler in which the boiler pressure is below the critical pressure, that is the 221 bar, and supercritical boiler are those boiler in which the pressure inside the boiler drum is above the critical pressure 221 bar. Example of the subcritical boiler is LaMont boiler and supercritical boiler is Benson boiler. We will discuss the one by one. So LaMont boiler, it is the four circulation boiler in which water is circulated through external pump through long closely spaced tubes of a small diameter. The mechanical pump is applied in order to have an adequate and positive circulation in steam and water. These are the basic diagrams of LaMont boiler. Here the basic components are to be given. These basic components are the feed pump. This one is the feed pump, another is the economizer, convective evaporator, radiant evaporator, and this one is the separating drum, and this is the circulating or the centrifugal pump. And in addition to that, there is one device which is called the air preheater. The water which is coming from the hot wells is sent or the pressed to subcritical pressure and it is sent to the economizer where the water temperature is increases and it goes to the separating drums. This separating drums separates the steam at the upper portion and the water at the lower portion. At the bottom side of these separating drums, the water is to send back through centrifugal pump which is driven by the turbine to the radiant operator. This radiant operator is very close to the furnace. Here the water is to be evaporated through the radiant heat transfer. Now the water is converted into the steam. Again this steam or the mixture goes to the convective superheater, and here this mixture is converted to the saturated steam and it goes to the steam drum where steam to be separate out, and it finally goes to the superheater and steam is get superheated by the flue gases and it has to be further utilized to run the prime mover. And one accessories which is the air preheater supply the hot air to the furnace, and this air preheater utilize the flue gases to heat the cold air and send back to the combustion chambers. These are the LaMont boiler. So as far as the pressure range of this LaMont boiler is concerned, the pressure is 170 bar to 170 bar. What is the below the critical pressure of the water, and the temperature is 770 Kelvin, and the heat and the water evaporation capacity is 50,000 kg per hour. These are the subcritical boiler. And as far as the advantage and disadvantage of the subcritical boilers are given, it can be easily start. It generates the high generating capacity 50,000 kg per hour. It has high heat transfer rate. The boiler can be reassembled with the natural circulation boiler. It design very simple. As far as disadvantage is concerned, there is a bubble formation inside the surface of the tubes. It reduces the heat transfer rate of the steam. Now another class of the boiler which is the supercritical boiler, or sometimes it is called the one stroke boiler, is called the Benson boiler. It has to be developed by the Mark Benson in 1922. The boiler can generate the high pressure steam which is further utilized for the production of electricity and the process work. Basically it is a water tube boiler. In the early stage of water tube boiler, the generated steam was having the pressure range of 100 bar, which is known as subcritical boiler. The two big problems basically faced by the subcritical boiler. In case of the subcritical boilers, vapor bubbles are to be formed, which hinders the transfer of heat. As a result of the heat, thermal efficiency of the plant get reduced. The second drawback of the subcritical boilers are there, that the big size of steam separating drums are to be utilized for separating the heat, so for separating the steam from the water. So, and that separating drums is very difficult to handle from one location to the other locations. The following parts for the Benson boilers is to be given. As in case of the LaMont boiler, the parts are the same, but there is slight difference in pressure which is to be given to the feed water. So the basic parts of the Benson boiler: the furnace, feed pump, steam outlet pipe, air preheater, economizer, radiant superheater, convective superheater, and convective evaporator. The principle of this Benson boiler is that here the water is to be placed just above the critical pressure of 20-25 bar. When the pressure of the water is increased to the supercritical level, the latent heat of water becomes zero, and to do this, it directly changes into the steam without boiling, and this prevents the formation of bubbles at the tubes. The feed water increases the pressure of the water to the supercritical pressure, and then it enters to the economizer, and from economizer the water passes to the radiant heater. Here the water receives the heat from the radiant, and part of this is converted into steam. After that, mix of the steam and water into the convective evaporator, where it is completely converted into steam and may superheated to some degree. Finally, it is passed through the superheater to obtain the desired superheated state. This superheated steam is then used for a turbine to run the engine to produce electricity. These are the basic layout of the Benson boiler. The function is same here. This feed water pump is compressing this water up to just above the critical pressure. It goes to the economizer, and here some part of the heat is to be utilized by the flue gases, and the water is converted into a mixture form, and this goes to the radiant superheater. The temperature of the water is to be increased, and the mixture is to get converted into more dry form. Here the convective evaporator, and the here a mixture get converted into the saturated vapor. It is then converted into the superheated vapor, and finally it is to be utilized for the turbine as a superheated vapor. As far as the advantage is concerned, this boiler do not utilize any boiler drums, so the overall weight of this boiler is 20% less as compared to the LaMont boiler. It is lighter weight and occupy the less floor area because the drums are missed, and it can be started within 15 minutes. It avoids the bubble formation due to the supercritical pressure of water.